Okay, so this is 3.13.2 variable velocity and uniform acceleration. We have this nice formula. Final velocity, acceleration equals final velocity, or essentially change in velocity. Final minus initial is change in. You'll sometimes see this as delta V over time interval or delta T. Um, you've also seen this formula in your physics packet. So, and here are all my equations that we talked about the other day. So here we have example one. A particle moves with a constant acceleration given by I plus 4j meters per second squared at time t equals 3 seconds. P has a velocity of this. Find its initial velocity. So we know, I'm going to start by writing out our knowns and unknowns. We have A equals I plus 4j hat meters per second, which means if I want to put this in matrix notation, that's 1, 4 meters per second squared. T equals 3 seconds. V, this is my final velocity. I'm looking initially for its initial velocity, and then we'll do its initial speed. So initial velocity, or final velocity is negative 3 I hat plus 2j hat. That's in meters per second. I put it in matrix notation, which is probably easier. Again, negative 3, 2. So I have an equation, V equals U plus AT. I believe that's one of my equations from above. Yep. So now I've got my knowns and unknowns. Very big key in this process. Unknown, I usually put a question mark by. So now I just have to plug it in. Negative 3, 2 equals U vector. These could all be thought of as vectors. Plus 1, 4 times 3. So here I get 3, negative 3, 2 equals U plus 3, 12. I'll move this vector to the other side by subtracting it. I can make it look like addition. Might be easier to look like that. And I get negative 6, negative 10 is my initial velocity vector. To find its initial speed, oh, I copied my knowns and unknowns wrong. Sorry, mistake here. That's a minus. It needs to be a minus, which makes this a negative, this a negative, that a negative, this a negative, that a positive. and it changes. Now I've got 2 plus 12 equals 14. So my velocity vector is this. I should probably give it in the original notation. If I want its initial speed, I'm just going to use Pythagorean theorem. And I get accurate 15.2 meters per second. So not too terrible if I just put it in vector notation and use my equations. Let's look at example 2. A particle moves with a constant acceleration at time t equals 1. Okay, again, I'm just going to start with knowns and unknowns. T equals 1 second. Has velocity, negative 3 I hat plus 2 j hat meters per second, which in vector notation is this. Or kind of in matrix notation. At t equals 3 seconds, it has velocity negative I hat plus j hat, or negative 1, 1. So, something I can do here to find its acceleration. I don't have to know more. I can call this u, change this to 0 seconds and this to 2. This will then become 4 from my u. So it has a constant acceleration, which means it'll accelerate the same from 1 to 3, from 0, ultimately from 0 to 1, 1 to 3, and 3 to 5. But now, if I change those, I can just use my equation. V equals U plus a t. So V, I'm going to use my second one. It's 2a. I'll move that to the other side by going 3, negative 2. So I'm subtracting it or adding the opposite, giving me 2, negative 1 equals 2a. When I divide both sides by the scalar 2, I get 1, negative 1/2 is my acceleration. So now if I want it at 5 seconds, I can just change, now that I know A, I'll do this in purple over here. I'll do V equals negative 3, 2 plus, that was actually 4 seconds after my time at 1 seconds. So 4 becomes my T. A is 1, negative 1/2. Negative 3 plus 4 times 1 is 1. 2 plus 4 times negative 1/2 is 0. What's my velocity? So I suppose I should answer my acceleration as a vector. I minus 1/2 j hat. Should answer this as a vector, just I hat. This has a unit of meters per second. This is a unit of meters per second squared. I guess I should put parentheses around my vector forms when I've got units. Okay. Again, if you write your knowns and unknowns, realize that your initial can be whatever you want. It's just time after that. T is the change in time. So I don't care how many seconds, I just care how many seconds from what I called initial. Okay. Example 3, the acceleration of an object A is given by 122 meters per second squared, has a velocity of 232 meters per second at time t seconds. Find the velocity of the particle after 3 seconds. So they're saying it has the velocity 232 ultimately as an initial at t seconds. Find the velocity of the particle 3 seconds later. So again, we're going to use our knowns and unknowns. My A vector is 1, 2, 2 meters per second. My V vector, not my V, my U here for my initial velocity is 2, 3, 2. And I'm asked to find, I'm told T equals 3. I'm asked to find V in the first part, and then I'll be asked to find S. So, again, this is my equation. V equals U plus AT. That's probably a nicer V. U 2, 3, 2 plus T is 3, 1, 2, 2 gives me a velocity of 2 plus 3 is 5. 3 plus 6 is 9. 2 plus 6 is 8. And that is my velocity vector. Find the displacement. Well, I need my displacement equation. Let's do that in blue. My displacement equation is going to be S equals well, probably the easiest one is 1/2 U plus V times T. There are others that probably would work too, but U being 2, 3, 2 plus V is 5, 9, 8. This is essentially average velocity times time, which is 3. So time is 3 here. So 2 plus 5 is 7. And 3 halves. We'll multiply the 3 times the 1/2 while I add the insides. 7, 12, 10. 21 over 2, 18, and 15. That is my displacement vector. And that is all for this uniform acceleration. Now it's time to head to the next section. 3.13, variable velocities in two dimensions. So ultimately, we're going to get here into projectile motion. A particle has a velocity given by 15, 3 plus 4t meters per second. Find the speed given t equals 10 seconds. So speed, just using the Pythagorean theorem, okay? So my velocity at this time is going to be 15. 3 plus 4 times 10 is 43. Now I need my speed. Magnitude of the v vector. Remember, magnitude looks like absolute value. Is going to be, this shouldn't be an equal sign. Use Pythagorean theorem. It says that 3 sig figs, the magnitude of the velocity is the speed, equals 45.5. My velocity vector was in meters per second, so my speed will be. Now we are going to get to a projectile motion. A projectile moves freely under the action of gravity and has initial velocity of 710. Take the velocity, find the velocity of the projectile after 4 seconds. Take that the acceleration due to gravity is 9.8 meters per second squared. So, they want me to find the velocity. So, again, knowns and unknowns. I'm looking for v. I know that u is 710. A, this takes a little bit of knowledge, but it shouldn't be rocket science. Gravity doesn't pull anything in the horizontal direction, so the A, the 9.8, only applies in the y direction, so the acceleration vector is 0, 9.8. Okay? I know that t is 4. Back to my basic equation here. U plus AT so V equals 710 plus T is 4. I usually just put it in front. The 9.8 actually should be a negative. The acceleration is downward. The velocity in the only part in the x is 7. And if I do 10 plus 4 times negative 9.8, I get negative 29.2. This is the velocity in vector form. And there is our answer. Okay. You could use some of the other answers to get its position. Okay. Or some of the other equations. But that is sections 13.2 and 13.3.